Hello friends, welcome to this channel, and we are continuing with our series on the configuration of Siemens decentralized busbar protection schemes, which we have started long back, and recently we have concluded our second session wherein we have discussed about how to assign or how to link this bay unit to your central units. And also we have discussed in the last session about the different meaning of the different settings available in the central units. In the first session we have already discussed how to draw the substation configuration, how to link the different bay units into your substation configuration, and we are continuing with the same project, that is busbar English demo. And if you can recall, then in the first session we have discussed about this inside the setting substation configuration. The thing was, we consider 8 bay units, 4 of which are connected to bus 1, the other 4 which are connected to bus 2. We have already discussed that how to link these isolators or disconnectors, breakers, CT, what are the precautions to be taken while connecting these CTs, then how to add these measuring blocks, that is the bay currents, then the differential current, stabilization current, everything we have discussed in the first session itself. Then the meaning of this normalization current and how to select this normalization current. In the second session we discussed about the bay unit allocation and also about the meaning of some of the important settings related to your busbar protections and the monitoring functions like ID supervision and the treatment of disconnector status malfunctions or disconnector jamming status, that we have discussed in our second session. In today's session we are going to discuss about the configuration and basically the configuration of the input and output in the bay units of the decentralized busbar protection schemes. So now, without wasting any time, let us start with today's session, in which we are going to discuss about the configuration of the input and output in the bay units of decentralized busbar protection scheme. And before discussing about this configuration of input and output, you must have one scheme according to which we are going to configure. That's why I have considered one simple scheme, and in this scheme what I am going to discuss is that this is a bay units. In this bay units you are having, suppose this is your 7SS525, which is a bay units. In this bay units, what are the things that you will have? If you see here, you will have the CT inputs for the measurement of the currents. Then you will have some inputs, binary inputs, and some binary outputs. Now we will discuss what are the important binary inputs, how to configure these binary inputs, and what are the important binary outputs, and how to configure those binary outputs in your bay units. So now if you see here, in the first or in some of the previous sessions regarding the LBB protections, which we have completed through 2 different sessions, and the video is already available on this channel. So therein we have discussed about the concepts of LBB protection, that is what is the meaning of back tripping, what is the meaning of inter tripping, how to implement the LBB protection in case of 1.5 breaker scheme, how to implement the LBB protection in case of double main or double main in transfer schemes. So I am not going to discuss about these things again here. I am going to discuss only about the configuration of inputs and outputs, and for that purpose, for the understanding of the input and output, some of the concepts that you must understand, that I am going to discuss in this session. So if you can recall from the previous sessions about the LBB or the breaker failure protection, so what are the things? Suppose this is one bus in which this is your one circuit breaker, this is the second circuit breaker, third circuit breaker, it is connected to suppose your second bus, and this is a 1.5 breaker scheme, wherein this is one feeder and this is a second feeder. You may have the numerous feeders connected to this bus 1, and at the same time multiple feeders connected to bus 2 also. Now suppose there is a fault on this feeder 1, and after this fault, what are our requirement? The requirement is this and this, that is suppose the breaker 1 and breaker 2 must trip to isolate the fault. But suppose due to any reason this breaker opens, but this breaker fails to open. Now, if this breaker fails to open through the main feeder protection, then what happens? Immediately when the feeder protection operates, so immediately when the feeder protection operates, it will send a signal to your LBB or breaker failure relay indicating that there is a fault in the system. And suppose after a lapse of a certain time delay, maybe suppose 100 milliseconds, this current through this breaker doesn't falls below the minimum threshold, then this breaker failure protection will assume that your fault is not cleared and it has to take some action. Now what action it will take? First of all, it will give a trip command uh, to this circuit breaker. So your LVB or breaker failure relay will give a trip command after lapse of some time to the same breaker, and that command is called trip repeat. Now suppose even after this trip repeat, this breaker fails to open. So now what are the possibilities? So now this breaker failure relay must trip all the other breakers connected to this bus, and at the same time it should trip this tiebreaker if not already tripped and send a direct trip command to remote end. Then only this breaker will be isolated. So now this second stage, which is your the final trip, in this state there are two things. So in the final tripping, will be the final tripping, there are two different things for the self bay unit or for the same bay unit and for the adjacent bay units. So what is happening to the adjacent bay units? In the adjacent bay unit, it will trip only the breakers, trip only the CB connected to the bus. CB connected to the bus. But in the self bay unit or in the same bay unit, what it had to do, it must trip its own CB, that is the main CB. It should also trip the tri-CB, that is this CB if not already in the trip condition, and it should send a direct trip command to the remote end. That means there must be two different types of signals that you have to assign for the LVB final tripping. And these two signals, one of this is called your bus bar intertrip in case of Siemens decentralized bus bar scheme. And the second signal, which is being sent to the adjacent bay units, is called CBF trip. So you will have three different signals. One is trip repeat, that is trip repeat is one signal. Then you will have bus bar intertrip and CBF trip. These three signals will be related to your LBB protection. But what in case of bus bar protection? So in case of bus bar protection, suppose again this is now I am considering only one bus bar with suppose 4 or 5 feeders. So this is suppose your 4 or 5 feeders, and you will have bay units connected to all this. This is not 4 or 5 feeders, 4 or 5 bays. So you will have this. Now this is suppose 5 bay units, and suppose there is a fault on this bus bar, then what should happen? That all this breaker must trip. So now all the central unit will send a signal to all the bay units that trip the breakers which are connected to the bus, and this happens in case of bus bar trip. So now you, if you combine all the signals, you will have four different types of signals that you have to configure. That is, one is for trip repeat, another is for your CBF trip, then your bus bar intertrip. These are basically three signals for related to LBB or breaker failure, and one output is your bus bar trip. So this is your fourth output, that is bus bar trip. So now I am going to discuss about the scheme. So if you see here in this scheme, you are having suppose 5 or 6 output. So now before going to before discussing about this 5 or 6 output, if you see here in this Siemens decentralized scheme, you will be having some binary input and some binary output. Input I am going to discuss very shortly. Then output, there are two types of output in this, that is trip output and one is signal relay. And this you have to see as per your scheme which is assigned to which, and I will consider our scheme that is already over here. And there are basically 5 trip output, that is trip relay and one signal relay. So there are 6 output relays, and I will discuss about the configuration of all these 6. Then the input. So now if you consider what input do you need, you definitely doesn't need any input. No input is required for bus bar in case of 1.5 CV scheme. So you doesn't need any input for bus bar, but you definitely need input for LVB protection. What are the input that you need? You must have the input regarding the faults, that is the fault is in which phase. So you must have the input that is R phase, Y phase, B phase and 3 phase initiation. So these initiations that will come from your main CV, protection. So this is R phase, Y phase, B phase and 3 phase initiation. So by default there will be only 4 inputs in any bay units, and definitely these 4 bay units are for your bay units which are for the line base or line protections. Because in case of your transformer and reactor, we generally consider the fault as permanent and we doesn't have this phase wise initiation, and we will have only 3 phase initiation, only 3 phase initiation in case of transformer protection. So now I am going to discuss about these things. So if you see here, uh, this is R phase initiation, Y phase initiation, B phase initiation and 3 phase initiation. These are your 4 binary inputs. I'm not going to discuss about this CB open and CB close at present because this is presently irrelevant. I will definitely discuss about this CB open and CB close during our discussion on end fault protection, and what are the meaning of end fault protection, how to implement this end fault protection, and what precaution we have to take during the implementation of this end fault protection. Then after this input, if you see here, there are some outputs, and these outputs are K1, K2, K3, K4, K5. These are 5 trip outputs, that is 5 outputs, and M1 is your signal relay. So now if you see again here, this K1, K2 and K3. So this K1, K2 and K3, this is suppose this 707 is any breaker, then for this 707 breaker this K1, K2, K3 is only for TC1, TC2, TC1, TC2 of Y phase and TC1, TC2 of B phase. That means these 3 outputs are connected with the tripping coil of the same circuit breakers. That means you can assign these 3 output to trip repeat during the LVB protection. Also, we can assign this output for busbar trip. Why? Because during the busbar trip, if suppose during the busbar fault, suppose busbar protection operates, then it can isolate the fault through the opening of circuit breaker, main circuit breakers, uh, via its tripping coil directly. You can also assign this output to this LVB trip, and in both cases, that is for the same bay units or for the same breaker or for the adjacent breaker also. Then the next output, that is your signal relay, it is assigned to your 86.1 relay. Now 86.1 is basically your master trip relay of group 1. So 86 is master trip relay of group 1. Now again, in which conditions you can trip this master trip relay? So definitely you can assign your output corresponding to bus bar trip, output corresponding to breaker failure trip, and in both for the cell and for the adjacent bay. You can assign. And during the operation of bus bar or during the operation of breaker failure, this 86.1 will trip and it will issue the tripping command to, or 86.1 will operate and it will issue the tripping command to your circuit breakers, and the fault will be isolated after the opening of the circuit breaker. But there is one important thing. Can we assign this 86.1 to trip repeat? The answer to this is no. And why no? Because in the Siemens relay or in any scheme, if you can remember, the initiation R phase, Y phase, B phase, that is the single phase initiation. This is single phase initiation. This single phase initiation will come directly from the main protection relays. That is the feeder protection main 1 or main 2 or through any auxiliary relays, single phase tripping auxiliary relays. This will come from here. The three-phase initiation will come from the operation of master trip relays only. So now if you see, suppose there is a fault in the system and suppose this is a R phase fault or this is any Rn fault. So with this Rn fault, what happens? Your bay unit will receive R phase initiation, and after the lapse of 100 millisecond, it is issuing trip repeat. Suppose this trip repeat is now assigned to the master trip relay 86.1. So what happens with the operation of trip repeat? This 86.1 will operate, and after the operation of 86.1, since it is connected to your three-phase initiation, the busbar unit or bay unit is again going to receive now the three-phase initiation. So now what happens? Earlier, there was a fault in R phase, and because of the R phase fault, it is receiving an R phase initiation, and after 100 millisecond, it is showing trip repeat, and we are expecting that after 200 millisecond or after the lapse of additional 100 millisecond from trip repeat, it is going to trip your bus bar. But since now it is receiving the second initiation, the three-phase initiation, uh, through with the operation of 86.1. So now what happens? Earlier it has single phase initiation and now it has three phase initiation. Immediately when this relay receives three phase initiation, it will discard this single phase initiation and it will start calculating the time from this three phase initiation. And now after the lapse of 200 millisecond, it will issue the final trip. So what happens? Your final trip will be issued from the fault inception time after the lapse of 100 plus 200, that is minimum 300 millisecond. This is not a problem till your fault is getting cleared within 300 millisecond, but there is a chance that this might take up to 350 or 360 millisecond, and in that case it might happen that the remote end lines in which your zone 2's timing is less than or equal to 350 milliseconds, those lines are going to trip before the operation of LBB protection. That's why we should never assign this 86.1 or 86.2 for trip repeat in case of Siemens decentralized busbar protection schemes and in case of your configuration of the unit's output signal. So again, uh, see this, we have discussed this output, we have already discussed this. Now the next is your aux relay circuit for LBB protection. Now what is the meaning of aux relay circuit for LBB protection? If you see here, suppose I am going to consider only uh, two breakers of one feeder, this is one feeder, and remaining I am going to consider suppose only main base. So now what happens? What is the meaning of LBB? Here this LBB means the LBB operation of this particular bay units. So LBB operation of this particular circuit breaker, LBB operation. Now what happens when the LBB operates for this breaker? It should issue trip command to this, this, all main CBs. At the same time, it should issue the trip command to its own tie CB and it should send a direct trip signal to remote end. So when it sends the tripping signals to the adjacent feeder, that is your CBF, that is your sorry. So it is going to send the CBF trip to the adjacent breakers CBF trip, and for the own CB it should issue only the bus bar inter trip. So if suppose any output is for the LBB operation in your bay units, so you have to assign this in the particular bay unit. This signal should be assigned as bus bar inter trip only. For LBB of the same bay units doesn't assign the signal CBF trip. If you assign CBF trip, then what happens? This output, suppose output number 4, this output will be energized. If it is CBF trip, this will be energized even during the operation of LBB of the adjacent feeder, and once this output is energized, it is going to trip your main CB, tie CB, and it is going to send the DT, and this is not at all desirable. So for the LBB operation of the same bay units, of the same feeder or same circuit breaker, you should use bus bar inter-trip only. Again, going back, so I have discussed about this output number 1, 2, 3, and 5 signal relay. The last one, it is for the bus bar trip. So this is very simple. Now I am going to discuss about the configuration of the input and output in case of your Siemens De-Centralized busbar scheme. So now going back to this bay units. So if you double click on any of the bay units, so now here you can see this is the SIPROTEC 3 series device. So all the bay units are generally are SIPROTEC 3 series devices, and in this device you can communicate the device only through front port or via central unit. Again, via central unit you can communicate, but from the front port of the central unit only. You cannot communicate any bay unit via central unit from control room or from DRPC. So in some new schemes, in some new projects of Siemens, they are providing the additional communication cards or additional communication circuit for communicating your bay units through rear port or over the Ethernet. But in older schemes or in uh, most of the substations, this bay unit you must communicate only through the front port. So if you are having the latest project and if you are sure this project is the latest project, then it is well and good. Otherwise, first of all, communicate with your relays to the front port, all the bay units, and save the settings, save the configuration in your laptop, and then start working. Since I am going to discuss about the configuration for the first time, I am using this offline mode, and now I will click OK. If you click OK, it will open in a very few seconds. And now if you see, there are some parameters here like parameter, enunciation, and fault values. For input and output, you must go to this enunciation, click on, you must go to this parameters, and inside the parameters, you should go to this marshalling. And if you click marshalling, you will have the here binary input, uh, then the signal relays, trip relays, and LED indicators. First of all, I am going to discuss about the binary input. So to configure any binary input, just double click, and now you will be having 10 binary inputs. Suppose you want to configure binary input. I'm going to configure the same scheme. So in this scheme, if you see here, what is I'm going to do is the input number 1 to 5. I'm going to use input 1 to 5 as a spare. Then input number 6, 7, 8, 9 as R phase, Y phase, B phase, and 3 phase initiation. So now how to do this? So first of all, you must go here, and now this is your binary input. So suppose I'm going to click binary input 1. So suppose binary input 1 is not required. So just double click over here and select this not allocated. Again, just close, go to binary input 2. Suppose this is again not required, so not allocated. I am not going to discuss about all the spares because the allocation will be same. So I am directly moving to the input number 6. And suppose this input number 6 as per scheme is your R phase initiation. Input number 7 is Y phase, input number 8 is B phase, and 9 is 3 phase initiation. So now the first one, that is input number 6, which is your R phase initiation. So again, directly double click and select this circuit breaker failure start for phase L1, that is CBF or initiation or start for L1, that is R flag initiation. If you see over here, this is active with voltage. So if you can recall or remember the configuration of 7SS522, wherein I have discussed about the configuration or the marshalling uh, binary input as H or L, so that is active with voltage or active without voltage. So whenever DC voltage at this input is present, then only this input will be activated. So this is for R phase initiation. Similarly, suppose input number 7 is for Y phase initiation. So input number 7 is for your Y phase initiation. Just go on here. This is Y phase initiation. Then input number 8 is for suppose B phase initiation. So just go here, and this is suppose your B phase initiation. And the last one, that is ninth number, is suppose your 3-phase initiation. So I'm again going to select, that is circuit breaker start 3 pole, circuit breaker failure start 3 pole. So this completes the configuration of binary input. Now we will move to the configuration of the trip relays and signal relays. So first of all, trip relays. Trip relay, you will be having 5 trip relays that I have already discussed. These 5 trip relays. So in these 5, first of all, the trip relay 1, 2, 3, these are assigned to your tripping coils. So now, since it is assigned to your tripping coils, so what we have to do is, we will go here, trip relay 1, it is assigned to tripping relays. For better understanding, what I am going to do, I am going to remove all the pre-existing allocations. So just remove all these allocations from here. This is very simple. Remove these allocations from here. So once you have removed all this pre-existing configuration, so first the output number 1 is for trip coil. So you have to assign some 4 different signals to this output. What are those signals? So first signals that you must assign is this bus bar protection trip. So whenever there is the bus fault, so your main breaker must trip, and for tripping there you will have this signal bus bar protection trip, that is 7631. Then what next? Next you have to assign for the trip repeat. So for the LVB protection, that is trip repeat phase L123. Next you have to assign for your same breaker LBB, that is inter-trip. And last one you have to assign for the LBB operation of the adjacent bay, that is CBL protection trip. So this completes the configuration of trip relay 1. Similarly, for trip relay 2 and 3, it will be also be the same. So first I have to remove this configuration, pre-existing configuration. So just go on clicking and removing this. Just keep on selecting this as not allocated. So this is again for binary output. I am going to remove all the pre-existing allocations, which is all very simple things. So just remove, and now I'm going to assign for trip coil 2. Again, you have to assign all 4 signals. First one is your 7631, that is bus bar protection trip, and then 3 signals related to your LBB protection. So first one is your bus bar protection trip, phase L1, L2, L3, and then 3 signals related to your LBB. So what are those 3 signals? First one, it should be the trip repeat for the same breaker, then the LBB operation of your same LBB operation from same bay units, and then last one, the LBB operation from adjacent bay units. So this is the very simple things, but you must understand the meaning of different signals before assigning. Now going to the third trip relay. Again, the third trip relay, the assignment will be exactly the same like the assignment in your trip relay 1 and trip relay 2. So now for trip relay 3, again we have to assign for the trip relay 3. If you see here, this trip relay 3 is again only for the tripping coils. So like your output number 1, output number 2, the output number 3 is also only for the tripping coils. So now just go here, and for output number 3, again assign first of all it should trip during your operation of bus bar, and then for the three signals related to LBB. One is 7639, that is before that first we will select the CBA protection trip repeat, that is L1 and L3. Then the LBB operation from the same bay units, and the last one, that is the LBB operation from the adjacent bay unit. So this completes for your output number 1, output number 2, and output number 3. Now, if you see here, the fourth one is for signal relay, and this is for 86.1. If you remember, for the signal relay, just go to a signal relay, and if you can remember, for the 86.1, I've already explained that you cannot assign this master trip relays for trip repeat. So you have to assign the 86.1 operation for the during the case of operation of busbar, and also during the case of operation of LBB protection, but you cannot assign this for trip repeat. So first you have to assign this for busbar protection. So this is busbar protection trip in phase L1, L2, L3, and then the remaining two signals, that is during the busbar protection intertrip, that is when your LBB protection operates, so it should trip 86.1, and through this your fault will be isolated by the opening of breaker. You can also assign this for the CBA protection trip, that is the operation of LBB from the adjacent bay units. This completes for signal relay 1. Now going back to the trip relay 4. So if you see here, this trip relay 4, it is it is for bus bar trip only, and this you have to see as for the scheme of your substation. I am considering one general scheme. You can consider any schemes, that is the scheme of your substation. So output 4 you have to assign only during the bus bar protection trip. So I am going to assign this only during bus bar protection trip. And the last one is for your operation of LBB protection from the same bay unit. So you have to assign this for your bus bar protection intertrip. You cannot assign this for CBF trip, because if you assign this for CBF trip, then what happens, even when your LBB protection of adjacent bay operates, then if you assign this CBF trip, so it is going to trip your main and tiebreaker and going to send the direct trip signal to the remote end via this output. So this completes the configuration of the input and the configuration of the output in case of bay units. I hope whatever concepts are explained in this session are clear to you. And if you think that this session is beneficial to you, and if you think that other persons might get benefited by seeing this video, then you can share this video with your friends so that they can also apply these concepts at their substation, and they can learn by practicing this through their own, and they can understand the configuration of the Siemens decentralized busbar protection schemes, the projects of their substation, and also we can develop a better community of protection engineers, wherein you can identify and rectify the defects in your busbar protection schemes at your substation. But before that, you have to practice these things in your own laptop or in your own PC, but doesn't change anything in your existing project before you understand the meanings of each and every signals which I have explained in this particular session. So thank you, and we will meet very shortly with the next session of this series. Till then, thank you and goodbye.